Hello and welcome to my section of the 3DN newsletter on engagement. And today I'm looking at engagement through modelling. Well, that's my section, and I thought that I would focus specifically on dual coding, so the use of diagrams for learning. So if we just have a look, this dual coding, the science was developed by a psychologist called Alan Piavo. He was a professor of psychology at the University of Western Ontario. And really interestingly, he was also a bodybuilder. When I searched for images in Google, I thought, I didn't think that these were the same people, but they are. But if we focus on his dual coding, it's the visual and verbal information act as two distinct systems in the brain. So you can think about a car by thinking about the word car, but you can also think about the visual image of a car. And if you can link those two information systems together, e.g. linking an image to a word or a concept, then it can aid students with retrieval practice. So if you can convert abstract concepts or intricate processes into visual structures, key ideas are explained in a way which is more computationally efficient for the brain. So I have developed what we're doing today from the Walkthroughs 2 book, and this is one of the images that's used to represent dual coding, but it's incredibly complex image, and if we were to just look at it we wouldn't really understand it, and that's because in order for this process to be successful, a teacher first must teach how to read and create the diagrams for their different purposes. So these are 5 steps in order to use dual coding effectively. So the first one would be to establish a visual or symbolic language. So in order to use the diagrams effectively, students need to be taught the common symbols you'll be using in diagrams. And the symbols need to be connected to their real life context that they experience, but also to the schema of your subject. So some examples being how circuit diagrams can relate to real circuits, how chemical symbols relate to particle diagrams and word equations, maybe using arrows to represent forces or flows, and also maybe how timelines work. The second key ingredient is representing just the essentials and leaving out all of the rest. You need to remove all of the information which is not essential to explain the concept you're trying to teach, because you want the brain to learn what the diagram. You don't need it to be focusing on all the other parts. So the symbols should be as simple as possible, but still identifiable for the students. You should really use block shapes instead of pictures so they're easily reproduced by the students and remembered, and then removing the background and any objects not involved in that particular process you're trying to teach. The third ingredient is representing process, movement and time. So teach students to produce or read your dynamic processes, e.g. using arrows to show the moving from before to the after. And don't just assume that students will know that that is what that arrow is representing. So you need to explain it to them. Establishing a code for the different movements you want to represent. So like moving from the before to the after, rotation, all those different types of movement that you might represent in your subject. And then using flow diagrams maybe to show processes which have different possible outcomes. The fourth part is generating in real time. This is, I think, the key part when you're linking together those two systems. So you're linking together the diagram system with the verbal information. It can be really powerful to create in real time a diagram with your supporting verbal explanation. Using a visualizer is an easy way to capture the steps of your explanation in symbolic form. It helps students see the process develop, to visualize the changes as they occur, and to understand the causal links, reinforcing your verbal narrative. And the last stage is then probably the bit that will allow you to determine whether they've understood your diagram. So reconnecting the representation to reality. So ensure students can translate diagrams back into their real situations. So it's assessment for learning, really. setting up an apparatus based on a diagram, providing a narrative of an event or a change process, but following the steps in the diagram, solving a problem that's been purely represented in the form of the diagram, and explaining maybe a phenomenon verbally using the diagram as reference. And again, that is so important for the students' revision there, so that they're not trying to remember lots and lots of words. They only need to remember the diagram, and they can reproduce what you need them to reproduce on paper from that diagram. So going back to this image, which is still complicated, but let's see how it has those 5 key ingredients. So what do the symbols mean? Well, actually, we don't have that key ingredient. We don't know what those symbols mean. We might know what some of them mean, but because we've not been taught it, we don't know what they mean. However, it does focus on the essentials, and we can see representation of time and movement with the arrows. If this had been generated in real time, then we would know what these symbols mean, and we would understand the processes that are happening with the arrows. And then to assess the learning, we would then need to reconnect it to the reality. So maybe describing what this diagram means to somebody else. Now, if you want to know more about dual coding, then there is a book by Oliver Caglioni, and he does explain this diagram, so you can go away and find out more. Okay, hope you enjoyed. Thank you very much.